the change of number of electrons being transferred. So if one gains 2 and the other gains 3, that can help us balance the reaction. I'm not going to cover that section, but I'm going to cover the redox reactions using the half reaction method. This is a very specific kind of balancing, and it's kind of fun once you get to know how to do it. So on this first particular slide, I'm going to go through the rules, I guess you could say, and then I'm going to actually balance this one that you see here. So make sure to get the list of how to, and then I'll show you what it looks like when we do it. So the first thing is you need to write a net ionic equation. For the most part, I will provide that for you, but that would be the first step. Here I've provided a net ionic equation. Then you have to write the two half reactions. You're then going to balance the two reactions separately, adjust the coefficient so that the number of electrons lost equals the number of electrons gained, and then you're going to add the reactions back together to get the overall answer. All right. Oh, and finally, if it's in a basic solution, we're going to add OH negative at the end to work it out. This is what I'm going to show you in class, the basic solution. So make sure, if I don't think of it, you ask me, because we definitely need to look at one that's basic. But let's look at the acidic one first, and I'll tell you, if you can do the acidic one, the basic one is almost as easy. So you can see the reaction. I'm going to move ahead. Same equation. All right, so let's see what to do. What we're going to do is we're going to figure out the oxidation numbers of these particular substances, atoms, or ions. So I'm going to show you, for example, iodine is worth -1, because there it is, and I2 is 0. So it went from -1 to 0. Chromium, oxygen's -2. Times 2 is -4. Oops, no, not -4, there's 7 of them. Let me erase, if it will let me erase. 2 times 7 is -14. Alright, now what we have to do is we have to figure out what the charge of chromium is, and there's 2 of them, and they have to add to -2. So I think it's, each chromium must be worth +6 each, because that would be +12 minus 14, and that's -2. Notice it over here, it's a +3. So there has been a change of charge of chromium. It's gotten less positive, and iodine's gotten more positive. Well, that makes sense, because one has to gain electrons and one has to lose. So we've written the net ionic equation was already given to us. I just wanted to do this to kind of get your mind thinking about oxidation number. Now what we need to do is we have to write the two half reactions. Let me erase these charges, because you don't need that for that. One of the reactions is I negative becomes I2. That's one of the reactions. The other is Cr2O7 -2 becomes Cr plus 3. So let's look at the first one. Okay, I can balance this because I can put a 2 there. So that looks pretty good. When you balance using the half reaction method, you are allowed to add some specific things. You may add water, you can add hydrogen ions because it's acidic, and you can add electrons. And you can add them to either side to make it balance for charge and quantity. So with the I negative going to I2, the number of iodines is equal on both sides, but the charge isn't. Here we have a -2 charge, and this side has 0. So I have to add 2 electrons to the right to make it work. And when I do, I have balance for charge and quantity, so that one is all done. Alright, let's look at the next one. Cr2O7 becomes Cr plus 3. Now you say, Normally we have the same atoms on both sides, but there's no oxygen over here, so I'm going to have to add some. And I'm going to add 7 waters. Remember, I can add water, hydrogens, and electrons. So I have to add 7 waters because I need 7 O's. Well, that has made things a little bit worse. Now I have 14 hydrogens on the right, and I need, therefore, to add 14 hydrogens on the left. Okay, that's helped hydrogen, but that's really messed up the charges because I have 14 positive charges here and 2 negatives here. So I have 12 positives on the left and only 3 on the right. So I'm going to have to add some electrons such that it equals the number of charge here equals the number of charge here. And when I work it out, I got 9 electrons, because that would mean this side is worth positive 3 and this side's worth positive 3. And that's what we want to have. They want to be the same on both sides. They don't have to be 0, they just have to be the same on both sides. In fact, let me draw a little line down there so you can see that they're 2 separate reactions. I'm trying to keep it all on one screen so it's a little confusing. Alright, notice also in these problems, here the electrons are in the products. So is that oxidation or reduction? Hopefully you said the right one. I'm not going to tell you. And this one, the electrons are on the reactant side. We are adding. They're gaining electrons. Hint. Reduction. Right? Gain electrons reduction, lose electrons oxidation. So we want to make sure that they have gained and lost the same number. This one has lost 2, this gained 9. It doesn't sound even to me. So we have to multiply through by something so that they have gained and lost the same. Unfortunately, 2 and 9, the number we'll have to multiply this by is 9, and this one we're going to have to multiply by 2 so that they've gained and lost 18. Seems like a lot, but sometimes that happens. So we have to multiply through. So this is 2 times 9, that's 18I negative, yields 9I2 plus 18 electrons. That's that one. This other one with 2, that's 18 electrons plus 28 hydrogens plus 2 Cr2O7 negative 2s, whoops, yields 2 Cr plus 3s and 14 waters. Now when I add these 2 equations, I'm going to actually merge them. I'm going to add them back together. I'm going to put everything that's a reactant on the left and everything that's a product on the right. Notice the 18s will go away because we set it up so that the electrons cancel. Therefore, combining them again, I have 18 I negatives plus 28 H pluses plus 2 Cr2O7 negative 2 yields 9I2 plus 2 Cr plus 3 plus 14 waters. And that is the balanced equation. Notice in the original we don't have any hydrogens, we don't have any waters, and we have to add them in as part of that. So we write the 2 half reactions, we balance them for electrons, and we re-add, and that is the half reaction method.